Guys, let's move on to the question number 5. How long does it take the second hand of a clock to move through 30 degree, right? Let me solve this problem for you. So, second hand, how long does it take? What's unknown here? We look for delta t. Delta t is unknown, right? And it's how long does it take the second hand of a clock? You know that every clock has let's say three hands. Hour hand, minute hand, and second hand. We focus on the second hand, let's say, because it talks about the second hand. Leave the information within the question, right? I want to, let's say, draw a clock for you. We have a clock here. This is, let's say, 12 o'clock. This one is 3 o'clock. This one is 6, and this one 9 o'clock. And the longer hand is called second hand, right? So second hand starts from where? Let's say draw it. It starts from 12 to 12, for example, to complete one revolution. How long does it take for the second hand to complete one revolution? Everyone knows the time interval for one revolution of the second hand, and is equal to 1 minute, or we can say 60 seconds. We deal with 60 seconds, right? And let's say it travels one revolution along the circular path. That's why delta theta becomes one revolution. And one revolution is equal to 2 pi rad. By means of this equation, you can find the omega average for every clock, for the second hand of every clock, not just for example, for a particular clock. So omega average is equal to delta theta divided by delta t. You see, I ignored the information within the question. I focused on the let's say clock, right? I ignored the information within the question. And I want you to do this whenever you solve such questions, right? Delta theta is equal to 2 pi divided by 60, and is equal to pi over 30. Pi over 30 what? Pi over 30 rad. This one is 30. Let me write it again. Pi over 30 rad. Let me circle it. So we need this, let's say, this information. Omega average is pi over 30 rad, pi over 30 rad per second, excuse me. Rad per second, because it's omega, for every clock, and even for every hand, let's say every second hand of any watch or clock all over the world, right? It's not just for a particular clock, right? So we have this information. And question gives us what? It gives us 30 degree. Delta theta is given is equal to 30 degree. I want you to convert it into the what? Into the rad. How do you convert it? Delta theta is equal to pi over 180. This is conversion factor multiplied by 30. And you can simplify 30 with 180. Delta theta becomes what? Becomes pi over 6 rad. So we have two information, right? We have two information. We have omega average, which is pi over 30, and we have delta theta, which is pi over 6. So which rule is convenient right now? The last step, actually, the last step. We look forward. It says, how long does it take? We use this rule. We use this rule. Let's say, rearrange this, the equation, actually. We use this one, because I did this one for you. And I forgot to write negative for you, actually, because it's a clock. Omega is negative, and actually this one is negative as well. Actually, it does not affect the answer because we look for delta t. Even you put, let's say, omega and delta theta positive, no problem, because you get eventually you get the answer in positive. It doesn't matter, but scientifically it's right. Scientifically it's nice if you put negative in front of the pi over 30 and in front of the pi over 6. So anyway, this is the last step, delta theta. We found delta theta. We convert it to this number, negative pi over 6 divided by omega, negative pi over 30. Divide these numbers together, far with far, near with near. Right? Far with far, if you multiply them together, goes to the numerator, becomes 30 pi, divided by near with near, I mean 6 multiplied by pi, goes to the denominator. In this situation, pi simplifies pi. 30 divided by 6 becomes 5 seconds. So the answer is 5 seconds. Which option is true? Among these options, this one is true. That's all, guys, for today. Thank you for watching this video, and bye-bye.